next step is to set up your batteries. We're going to go to battery, and we have two battery types. By default, the system will default to lithium. You have two types of communication, CAN and RS-485. The inverter seems to like the CAN setting better than the RS-485 setting. Once you have set lithium and you've made the connection, you want to ensure that your batteries are compatible with the inverter. Most batteries have settings in them to help you select a compatible communication type. You can use Pylontech or DE, YE, or die to communicate with the inverter. I'll flash on the screen the communication type that the inverter prefers. Next, we'll cover battery setup. There are two primary battery types that you can choose from: lead acid custom, and really this should just be labeled custom, and lithium. If you choose lithium and your battery has CAN communication, you can simply plug a standard Cat5 cable between the battery and the inverter into the battery COM port on the inverter, and by default most batteries will go ahead and communicate and work. If not, you can try setting your battery on your battery screen to a different communication type. So currently lithium is selected. We have CAN as the battery communication type. We have our charge current, and we can set this up to a maximum of 190 amps. That is what is on the specification tag for these inverters, and if you set it higher, the inverter may act strange and do some strange things with charging, so make sure you do not exceed 190 amps. For me and my setup, we're going to charge at 20 amps. For the discharge power limit, this is if you have the grid attached. If you set this, let's say, to 10%, this means that the inverter will draw 10% of its power from the batteries and 90% of its power from either solar or the grid. If you set this to 50%, then the inverter will pull 50% of battery power to the loads and then balance the rest of it between the grid and the solar. Now, if you do not have grid attached, it will simply balance the load between solar and battery. In my case, we're going to set this at 15%. Hit next. On the battery settings screen, underneath lithium, you have 4 options. If you are using custom, these 4 options are overridden by the custom settings at the top. Under lithium, you have low battery depth of discharge. This means the total depth of discharge. If you set it, say, to 80%, then that means there will be 20% of battery capacity left. So if I set the low battery discharge to 80%, this will allow, the inverter will allow the batteries to discharge to 80%. This will produce an alarm on the main screen letting you know you have reached your low battery depth of discharge. This setting, EOD historicity, allows for some give when you reach that 80%. So we're going to set that to 10%. We're going to set the low battery to 70. What that means is the alarm will go off that you've hit your low battery depth of discharge, but it will not stop the alarm until you reach 40%. So 70% here means there's 30% left in the battery. A 10% historicity means it has to get to 40% before your low depth of discharge alarm ceases. Shutdown depth of discharge, we'll set this to 90%. What this means is once it has discharged 90% and there's only 10% left in the battery, then the inverter will shut down all of the loads. We have a 5% historicity here, so that means that it will have to charge up to 15%, so at least 15% of battery life before the shutdown can be overridden. Something to note is the CAN ID. This is set up when you use a lithium battery type and you have BMS communication with the inverter. You want to ensure that there isn't a conflict between this CAN ID and the CAN ID on the first battery in your battery bank. Ensure by looking at the battery's documentation and manuals that the DIP switches are set so that you don't have a conflict with the CAN ID. Many batteries in their instructions will ask you to set the CAN ID with the DIP switches to 0, and then the next battery is 1, and so on. Sometimes this can cause a communication conflict with the inverter. If you run into a communication conflict, you can double check the CAN ID. Now we'll go over entering a custom battery configuration. I'm going to select lead acid custom. I'm going to save that setting, and I'm going to move to the next screen. In my case, my batteries are a 15S configuration. As such, I need to do a custom configuration for my battery settings. We are going to set our float voltage at 51, our absorption voltage at 53.4, our battery cutoff voltage at 43.5, our over voltage protection at 54.7, and since we have 4 batteries, we're going to set our battery capacity to 400 amp hours. And we're going to hit save. Now, this is for my specific battery bank. Like I said, I have 15S batteries that produce 48 volts instead of the 51.2 volts that you may be familiar with. Hit save. Now we'll go back to the main screen, and you'll see that the error for battery communication has been cleared. We have a 78.2% battery charge, and I'm going to check that with the charge state on the LCD screen on my battery.